It's my pleasure to introduce one of my favorite people to you, who's going to speak for a while. His name is Professor Thomas Jordan. He's a university professor, and for those of you who don't know, very few people are classified as a university professor. A university professor can teach any class, anytime, anywhere. They're above a full professor, so it's almost as good as it gets, but that's just the tip of his iceberg. He's a professor of earth sciences at the University of Southern California. He's the director of the Southern California Earthquake Center, and in case you want to know what that means, it means he coordinates an international research program in earthquake science that involves over 1,000 other scientists at more than 70 different universities. And he also is an elected member of the National Academy of Sciences. People like Einstein get elected to the National Academy of Sciences. And I think of Tom as the Einstein of seismology. Tom?
Well, I want to thank Marcia Stein and the Emergency Preparedness Commission of Rancho Mirage for inviting me and my wife out this beautiful time of year in the desert. We noticed the flowers on the way here. Beautiful place it is. The weather is perfect. But I'm going to talk to you about a difficult subject, and that's earthquakes. Let me calibrate the audience here. How many of you have felt an earthquake? Whoa, whoa, whoa. All right, now, how many of you have felt a very strong earthquake? Oh, okay. All right, so we have a room full of experts, that's clear. Let's start by just looking at where we are in the national scheme of things. This is the U.S. National Seismic Hazard Map. It shows us places in the United States where we can expect strong shaking from earthquakes. Those regions are in red. You notice we live in the red zone. In fact, all of California, the coastal California, up through the Pacific Northwest, and you'll notice Alaska also, have very high earthquake hazard, meaning that we expect at some point to have very strong shaking that can be damaging. Now, what's that going to do? Let's look at a different map. This is what's called a seismic risk map. This tells you where the damage is going to be done. And you'll notice all of a sudden Alaska is not so red. The reason for that is you can shake Alaska pretty hard and nothing much breaks because there's not much there. Whereas in Southern California, we have one of the largest industrial complexes in the world. So we really own the earthquake problem. In fact, about 40% of the national earthquake risk, in other words, that's long-term, where we expect the damage to be done, where the economic losses will be, is in Southern California. So I'm a director of the Southern California Earthquake Center, and part of our job is to work with the U.S. Geological Survey, the California Geological Survey, the California Office of Emergency Services to try to understand earthquakes better and to quantify their effect. Now, the title of this talk is Locked, Loaded, and Ready to Roll. And I want to try to describe to you why I use that. This is not an earthquake prediction, but it's simply a statement that we've got a problem. And here's the problem. You're looking at California tilted on its side, and this big red streak across California is our old nemesis, the San Andreas Fault, right out there. Up here is the North American plate, out here in, let's say, the Midwest. Out to our west is the Pacific plate. These plates are moving relative to one another. In particular, the Pacific plate is translating to the northwest at a rate of about 5 meters per 100 years. Now, what does that mean? Well, that San Andreas Fault is locked, meaning there's not earthquakes occurring on it, and therefore that displacement is not being taken up right now in the San Andreas Fault. but it has to be taken up at some point in large earthquakes. So in order to keep up with the plate system, the San Andreas Fault has to move at a rate of about 3.5 meters every 100 years. That's not the entire Pacific Plate motion, because some of that motion is taken up by faults to the west of San Andreas and to the east of the San Andreas. But actually, in the San Andreas system, we recognize about 3.5 meters per year. Now, of course, we've had a series of earthquakes on the San Andreas. For example, in 1906, the Great San Francisco earthquake ruptured the San Andreas over a 500-kilometer segment that stretched from Monterey Bay region all the way up to Cape Mendocino. That was a magnitude 7.9 earthquake, almost a magnitude 8. And you know what it did to the city of San Francisco. If we go south from San Francisco, there's a part of the fault here in black where there is slip occurring all the time, very slowly. It's what we call the creeping section. That section we don't think has big earthquakes. And it divides the northern part of the San Andreas Fault from the southern San Andreas Fault. Well, what about the southern San Andreas Fault? What do we know about earthquakes on the southern San Andreas Fault? Well, we know that in 1857, there was another very large earthquake that ruptured from Central California near the town of Parkfield all the way down to Cajon Pass, about a magnitude 7.8. The displacement in this earthquake was about 5 meters. So it took up more than a century's worth of slip from plate tectonics. Let's go further south. In 1812, there was an earthquake. We don't know too much about this earthquake because not many people were recording history at that point. But it ruptured in the San Bernardino area, up into the Mojave, down about to Banning. That was a magnitude 7.5, we believe. But it did not go south of about Banning or so. What about this section of the San Andreas Fault, right out here, the Coachella section? We don't know of any, there's no historically recorded earthquake from that part of the fault. But by careful geologic work, geologists have been able to show that there was an earthquake there in about 1715, and probably about a magnitude 7.4. So you can see this is the history of large earthquakes on the San Andreas Fault. Now let's subtract the time today from the time that those earthquakes occurred. That's what we call the open interval. So the open interval is just the time since a fault section ruptured in a large earthquake. And you can see that the open interval up here in San Francisco is 111 years since 1906. The open interval on the Fort Tejon earthquake is 160 years, 205 years, and 302 years for the Coachella section. Now the problem is that we haven't had big earthquakes that have taken up the plate motion. So the question is the southern San Andreas Fault locked, loaded, and ready to roll? And I want to describe some of the information about that in a little bit more detail. First of all, people will ask, okay, we have lots of small earthquakes occurring. Perhaps those small earthquakes help take up that slip. Nada. Doesn't work. The reason is that it's shown here in this diagram. You know, a magnitude 4 earthquake, we have 4s around here fairly frequently. They'll shake, you can feel them. A magnitude 4 earthquake is about a 1 kilometer by 1 kilometer patch of fault that slips only about 5 centimeters. A magnitude 8 earthquake is 10,000 square kilometers, and the slip is about 5 meters or more. So it literally takes millions of small earthquakes to add up to one big earthquake. So the fact that we're having small earthquakes does not release the stress that is accumulating on the fault. Here's a map of Southern California showing you all the little earthquakes, magnitude 2.5 and greater, that have occurred since 1990 to 2013. Very representative sample. And my question to you is, where is the San Andreas Fault? you can see some fault lines on here with these distributions of earthquakes. Here's the Elsinore Fault, here's the San Jacinto Fault, here's the Raleigh Seismic Zone. In fact, if we look at where big earthquakes have occurred in Southern California, you'll notice that these black patches are very often the aftershock distribution from big earthquakes like the Landers earthquake of 1992 or the Hector Mine earthquake of 1999. Did anybody feel those earthquakes? They weren't too far from here. Probably shook pretty hard. Where is the San Andreas Fault? This shows you, in fact, all of the earthquakes that have occurred since the beginning of the 20th century that are greater than magnitude 6. And here's the San Andreas Fault. Essentially, none of those earthquakes, in fact, none of the big ones, occurred on the San Andreas Fault. So that's what I mean by the San Andreas Fault is locked. Pressures are keeping that fault from sliding. There's a large frictional stress that has to be overcome in order for it to break. It's locked. It's also loaded. These are motion vectors derived from global positioning system, GPS systems, like the ones you have in your car or your phone, only more accurate. And we're able to monitor the displacement of various points throughout California. And what we see is we see that points on this side of the San Andreas, relatively speaking, are moving to the southeast, whereas points on this side of the San Andreas are moving to the northwest. And you'll notice there's a very sharp gradient right across the San Andreas Fault. And in fact, we can map that. And what you see here in the bright colors are the places where that strain is accumulating, where the loading is taking place. You'll notice it's a pretty narrow zone up here in the Carrizo Plain, pretty narrow zone down here in Baja, but a little bit more diffuse in the Los Angeles region because there's a whole series of faults, including big thrust faults that are taking up some of the strain. And you'll also notice that here in the Coachella Valley, there's it's sort of a wide zone, and that's because there are two major faults in this region, the San Andreas Fault, running through Coachella Valley, and the San Jacinto Fault that's just over the mountain. That's a pretty active fault. That fault might be taking up 1/3 to maybe as much as 1/2 of the total strain. But it doesn't get us out of the problem that the San Andreas Fault, throughout its length in Southern California, is loaded. Now, is it ready to roll? This is a hard question for we seismologists to answer. One of the things that we do at the Southern California Earthquake Center is dig trenches like this. This is a trench across the San Andreas Fault over at, this is actually in Coachella, and it's a sort of a massive trench dug across the fault. The fault's actually right about here. You'll notice how there's water on this side, no water on that side. The fault actually acts as a groundwater barrier. But what geologists can do is look in the side wall of these trenches, this region here, and they can map disruption of the sedimentary bedding in the region. And by seeing that a crack has occurred up to a certain level in the sediments, you can date when that was. You can get a record of earthquakes that occurred in the distant geologic past. And when you do that, here is the graph that you get. This is some form of some form of displacement occurring in earthquakes versus the year going for about the last 1,000 years. So this is the year 1000. The Norman invasion was in here. You will notice that this is a stair-step pattern. The stair-step pattern, you have periods where you have no earthquake, and then all of a sudden you get a big earthquake, periods of quiescence, big earthquake, quiescence, little earthquake, another little earthquake, and so forth. These are earthquakes that have been detected geologically in these trenches. This is from a whole series of trenches around this part of California. And you can see what's happening. These earthquakes are kind of keeping up with the plate motion. This plate motion, this is the 3.5 meters per 100 years. And you can see that what'll happen is you get the stresses will build up, and then all of a sudden they'll be released. They build up, they're released, and the fault is keeping up with those plate motions. But notice what's happened recently. There hasn't been any earthquakes in quite a while in this part of California. And so this curve is pretty flat, and we have a lot of missing slip. This is slip that someday is going to have to be taken up in earthquakes, and you'll notice it's not a minor amount of slip. It's a big arrow. It's bigger than any of these these are magnitude 8 earthquakes. So there is, in fact, the San Andreas is locked, loaded, and ready to roll in that sense. But what can we say about when a big earthquake is actually going to occur? Does anybody know? I don't know. Didn't hear that, but it sounded funny. Seismologists and various other scientists for 100 years have been trying to predict earthquakes. And they typically use what I call the silver bullet approach. What's a silver bullet approach? They're looking for what we call diagnostic precursors. What you want to have is some signal. You put some instrument on the fault, and you go and you record information. All of a sudden, you see a blip, and you say, oh, that means there's going to be an earthquake next week. And it's going to be a magnitude 7, and it's going to be on this part of the San Andreas Fault next week. Nobody has found such diagnostic precursors. And believe me, a lot of people have tried using all kinds of different techniques. My favorite is animal behavior. Right? Your dog, your cat can predict earthquakes, maybe, right? Some people think so. There was a guy who actually used the reportings of lost cats to try to predict earthquakes. Didn't work. In fact, a few years back, I chaired an international commission that was convened by the Italian government after the very destructive, deadly earthquake in 2009, the L'Aquila earthquake. And they asked us, okay, what can you say about earthquake prediction? And what we said was that the search for diagnostic precursors has not yet produced a reliable scheme for short-term prediction of large earthquakes. We don't know how to predict earthquakes. Now, that doesn't mean we can't say something about earthquakes in terms of when and where they might happen. We developed, in conjunction with the US Geological Survey, the California Earthquake Authority, the California Geological Survey, and our center, SCEC, we have developed models for earthquake forecasting in California. These represent primarily, we focused in the past primarily on the long-term probability of having an earthquake. So from the geologic record, we know where the faults are. We can see that earthquakes have occurred in the past. That tells us how frequently they occur. And we can see how big those earthquakes have to be to take up the fault motion. We can package all of that into an earthquake forecast. This is the latest forecast we have. It's called the Uniform California Earthquake Rupture Forecast, or USERF-3. It's the third version of this forecast that we've developed. It's just been recently published. It provides probabilities across the state for earthquakes greater than 5, both on and off known faults. It has been incorporated into the National Seismic Hazard Model. This is the official earthquake forecast for California. And what's interesting and what I want to emphasize tonight is that this model, for the first time, does have the ability to cast short-term probabilities based on seismic activity. And it's the first model for California to do so that recognizes the danger associated with the big faults. So I want to talk a little bit about this model. It's actually 3 different models. So what is this? Here's Rancho Mirage. Here's Los Angeles. These ribbon-like things are all the faults in our area. This one is the San Andreas Fault. It's more colorful because on this scale, it has a higher probability of hosting an earthquake of magnitude 7 or greater in the next 30 years. We use 30 years because that's the length of a mortgage. You buy a house, you want to know, is my house going to be okay for the next 30 years, right? You'll notice that the probability of having a magnitude 7 earthquake right here near Rancho Mirage on the San Andreas Fault is pretty high. It's about 10% in the next 30 years. So 1 in 10 chance. However, remember we said it's been 300 years since the last big earthquake occurred on this part of the fault? That must mean something. If we factor that fact in, the date of the last earthquake, the long length of the open interval, the probabilities go up. It becomes more purple. In fact, it go up to about 20%. It doubles the probability for this long interval. And in fact, if we look at the ratio between those, you can see the San Andreas Fault is sort of twice as likely to go as on a typical time. So what this is telling you is the San Andreas is locked, loaded, and ready to roll. Here's another way to put it. This is a more complicated graph. This is the 30-year probability, goes from 0 to 1, or 0 to 100%. Here is magnitude out to over magnitude 8. And what I just told you was that if we just take a random time, no particular time, the 30-year probability of a magnitude 7 earthquake on this fault over here is about 11%. If we take into account the fact it's been a long time since a big earthquake, that bumps up to about 23%. And you can compare that with the probability for having an earthquake of magnitude 7 or greater in the next 30 years anywhere in California. That's pretty high. That's up at something like 76%. So this is what an earthquake forecast can do for us in terms of the long-term probabilities of earthquakes. But what does it have to say about an earthquake, let's say, next week? Well, we can't predict earthquakes next week, but it doesn't mean we can't say anything. There is a new set of protocols that we've been developing called operational earthquake forecasting. This is the timely distribution of authoritative information about sort of the state of the fault system, about the probabilities associated with earthquakes, that is packaged in a way that we can actually can be used by society. Now, we know that seismic hazards do change with time. We can't predict earthquakes, but we know that earthquakes, when they release energy in the fault system, change the whole state of the fault system. And we have statistical models that describe these interactions. You know, if you have a big earthquake, you get lots of aftershocks. Those aftershocks decay away, but you can tell that the whole system's been jostled and it's actually means there's, when you have a big earthquake, it doesn't mean you've gotten rid of the earthquake. It means you're going to have more earthquakes because of this clustering phenomena. And we can use these to actually cast probabilities. The problem is we can't give high probabilities. We can say the probability of having an earthquake is 100 times or 1,000 times greater this week than it was last week, but we can't say, those probabilities are still small, still on the order of 1% or less than 10%. So there's a real issue. How should this information actually be used by the public? I'll say it another way. Suppose I told you, suppose you fly every week between LA and New York. The chances of that plane crashing are what, 1 in a million? So what if I told you that next week it was 1,000 times more likely that the plane was going to crash because I've got some special information about terrorism? Would you fly on that plane? Your chances are still only 1 in 1,000. So you don't take much risk going on that airplane. You probably wouldn't do it, would you? That's because the consequences are very high. So we always have to trade off the probability with the consequences. When the consequences are really high, we have to worry even if the probability of something happening is pretty low. And I can illustrate that with something that happened here in September of this last year. You probably recall that there was a swarm of earthquakes just in the Salton Sea, just in what we call the Brawley seismic zone, these red earthquakes that occurred here. They're typical. There's been swarms in 2001, shown here in yellow, 2009, we had a swarm, and then this one in September of 2016. Now, I sit on something called the California Earthquake Prediction Evaluation Council. We were asked by the Office of Emergency Service to evaluate the situation. And the problem that we were asking is, can these earthquakes here trigger an earthquake on the San Andreas Fault? Because the San Andreas Fault runs right up to these clusters. And we cast this in terms of a probability, and here's what we said. We said, the stresses associated with this earthquake swarm may increase the probability of a major earthquake, we mean magnitude 7 or greater, on the San Andreas Fault to values between 0.03% and 1%. All right? Now, that's small probability, but it's a factor of 160, 1% is a factor of 160 greater than the ambient regular probability. So Cal OES put out an alert the day that we issued the report. There was considerable discussion in the media about what all this meant. There were some short-term, low-cost measures taken. You may recall the San Bernardino closed their city hall. Their city hall is known to be seismically unsafe. They wanted to get everybody out of there in the next 6 months anyway. So they closed it for 2 days during this period of enhanced seismicity. The earthquake didn't occur. We wouldn't expect it to. 1 in 100 chance for it to occur. It didn't happen. But it did provide a very useful example for educating the public on this type of information. And my point is that this information ought to be available to you all of the time. We should tell you how the probabilities are rising and falling, even if they're only going up and down at fairly small levels, because you can use that information. Certainly, nuclear power plant operators, hospital operators are very interested in that type of information. Part of the reason we're worried about earthquakes in this part of California, this fault hasn't broken in a long time, so an earthquake might start here. And what would happen if that earthquake propagated up, not just through the Coachella Valley, but all the way up through the Mojave? Then it would become a magnitude 7.8 earthquake. And this is from an animation. I won't show the animation, I'll just show you some still photos of the ground shaking that propagates away from this type of earthquake. And you can see how bad the situation is. This is after 10 seconds from the start of the earthquake, and you can see the southern part of the Coachella Valley and Prieta Valley is starting to shake. Within 28 seconds, Palm Springs getting hit. 55 seconds, San Bernardino is getting hit pretty hard. And you'll notice there's a big pulse of energy that's running in front of that fault as that fault propagates. That's what we call the directivity pulse, a lot of energy going out there. And you would think it would go right up the fault. It does, except it takes a half-left turn, and the energy gets funneled through the sedimentary basins into Los Angeles, and you get very long shaking. So even 2 minutes after the earthquake, LA is shaking pretty hard. So these are the types of ground motion scenarios that we have developed. We're using supercomputers to do this. And we would like to be able to sort of forecast the ground motions associated with seismic activity that might occur. So here's an example of a scenario. I'll close on this example. This is a magnitude 7 earthquake that ruptures. This is just a scenario. It hasn't happened. But suppose a magnitude 7 earthquake ruptured sort of the central Mojave section of the southern Mojave section of the San Andreas Fault. That would cause a big shake. But what would happen after that? It's kind of my nightmare scenario because a big earthquake's just occurred. Everybody goes, oh, wow, finally that big one happened. We have to stand up and say, no. The probability of having another big earthquake is pretty high. And this map shows you that probability. All up and down the San Andreas Fault, an earthquake on part of the fault could trigger earthquakes all up and down the fault. And I wanted to give you just a picture of what the ground motion probabilities are for high ground motions here in Coachella Valley if an earthquake occurred up here in the Mojave. Now that earthquake would cause a good shake here, but most of the damage would be up in this region, not in Coachella Valley. However, because of the possibility of large aftershocks associated with this earthquake, in particular large events on the San Andreas Fault, the probability of having very large shaking, very high shaking, jumps up at that point. And it jumps up, and then it goes down. Here's the first 3 days. Here's the next 3 days. You can see the colors are getting cooler. And so the enhanced risk is fairly short term, but it's something that we need to be able to quantify, and we need to be able to give to the public so that people can use this information as best they can. So here are my conclusions. The San Andreas Fault is locked and loaded. There's enough energy that's been accumulated in the system to provide us with several very large earthquakes. We can't predict when these earthquakes are going to occur, but we do know that increases in seismic activity can increase the probability of those events, so we can monitor how those probabilities are rising and falling. We now have a model, USERV 3, that provides these short-term probabilities, And we are in a position now to put out seismic weather reports. All right, these are short-term reports on what's the probability is. It's not like your regular weather report. You know, you get mad at meteorologists because they say there's a 60% chance of rain and then it doesn't rain, right? Well, we'd be saying there's a 1% chance of an earthquake rather than a 1 in 10,000 chance of an earthquake. But that information can still be useful. And I'm going to now, I'm actually just the warm-up act for Dennis Mileti, who's going to tell us what do we do given all of this risk that we have around us from earthquakes in this part of California. So thank you very much.
Thank you, Tom. I'm going to talk about how Californians have responded to earthquake forecasts that seismologists like my colleague Tom and others have issued. And I took this definition of forecasts from a seismologist named Tom Jordan.
Fix it.
It's the dissemination of authoritative information about time-dependent probabilities to help communities prepare for potentially destructive earthquakes, to inform the decisions that people, that would be us, and organizations, that would be cities and counties, make to mitigate seismic risk and prepare, thank you, for potentially destructive earthquakes on time scales from days to decades. Sounds like something a physical scientist would say. Social scientists would say there are 4 kinds of forecasts from a human response point of view. There are short ones, forecasts made, for example, a 72-hour period, and long ones, for example, forecasts made for years and decades. And that there are 2 different environments in which these forecasts could be made. Forecasts made before an earthquake, as a forecast for our great earthquake might be made, or after an earthquake. And the purpose of my talk is to examine the history and review quake forecasts in California and what actual Californians did in response to them. And then to consider our future about what we should do if a big one in our valley has forecasts and what it might motivate us to do. The first case is regarding a forecast is the Loma Prieta earthquake. After that earthquake, there was a forecast. Here's what the forecast said. Imagine going through the Loma Prieta earthquake, and then you hear on your radio and TV that the physical scientists are saying, get ready, there's going to be another one. The USGS made this statement at 7:15 a.m. on October 18th in 1989. An analysis of historical earthquake sequences in the past 50 years in California suggests that there's a 1 to 2 in 10, 10% to 20% probability of a magnitude 6 or larger aftershock in the first 24 hours following the main shock and diminishing thereafter. The San Francisco newspaper reported this to its readers. Although the likelihood is remote, there's also a possibility of a magnitude 7 or greater earthquake in the coming days on an adjacent segment of the San Andreas Fault. At 5 p.m., the USGS said, as of Wednesday at 5 p.m., there's only a 2% chance of a magnitude 6 or larger aftershock in the next 24 hours. In the same period, the probability of a magnitude 5 or larger aftershock is 11%. And on the 21st of October, the USGS said at this time, there's only about a 1% chance of a magnitude 6 or larger aftershock in the 24-hour period beginning at 7 a.m. today. The chance of a magnitude 5 or larger aftershock in the same 24-hour period is 8%. So you turn to the person you live with and say, okay, what do we do? Particularly since on the 24th, seismologists reported that they advised that additional aftershocks are expected in the next few weeks to months, some possibly strong enough to cause additional damage, especially to structures weakened in last Tuesday earthquake. How many of you would know if your structure, your house, was weakened? You'd have to be an earthquake engineer to know that. Anyway, that's what went out. Okay, what did people think? We actually did a huge survey based on statistics to find out what people in the city and county of San Francisco did and what people did in Santa Clara County. 56%, about half the people understood the forecast. That's not bad. Almost 3/4 of the population believed that the forecast earthquake would happen. And you got to get in the skin of people. The only thing that's real for people is not physical science, is what they think is real. And they thought the next earthquake would happen. And 40% of the people in San Francisco and over half of the people in Santa Clara believe that when it did happen, they would have damage. Forecasts after earthquakes are a different ballgame than forecasts when no earthquake has happened. What did people do? People did things like seek out information. You know the brochure you're sitting on? You'll go looking for that in the house. They sought information about how to prepare. They read preparedness information in the phone book, which is where governments put it back in the late 80s. They developed an emergency plan. They made household items safer, and some of them made their homes structurally safer. The thing to look at is, by and large, people in Santa Clara did more than people in San Francisco. Do you see that? That's because the earthquake happened in Santa Clara, not San Francisco, and they had more damage. The next forecast is PARKFIELD, California. PARKFIELD, California, there's their water tank, and they declared themselves the earthquake capital of the world and invite us to be there when it happens. PARKFIELD, California had then a population of 28 people, half of whom grew marijuana for a living. I'm not kidding. It's also very close to the tree that Jimmy Dean died in a car crash. The forecast happened in November of 1984. I got to tell you about this. The physical scientists were trying to predict earthquakes. They were taking all this money from the US Congress, and they hadn't predicted any earthquakes. So a few people in the USGS said, maybe we should predict an earthquake or they'll stop giving us our research money. And somebody said, hey, I have an idea. An earthquake happens predictably in PARKFIELD every X number of years. Why don't we predict one, give or take, minus half X number of years? So they did. They said there's a 95% probability of a 5.5 to 6.0 magnitude quake, 10% probability of a 7.0 magnitude quake sometime between 1985 and 1993. This was going out on a limb. And the survey took the person in charge of the PARKFIELD earthquake prediction experiment, as it became called, and rotated them out of that job so that none of them would have their name associated with it if the earthquake didn't happen. So the USGS then called the California Office of Emergency Services and said, maybe you should tell the public. And the California Office of Emergency Services called a friend of mine and said, "You're a sociologist. Why don't you come up with a warning we can distribute to the public?" And my friend called me up and said, "Dennis, what should I do?" And so he and I worked up a brochure that was then direct mailed to everyone in the area that would experience the earthquake. 1 year later, after I got a National Science Foundation grant to study public response to the prediction, here's what we found out. Coalinga, Paso Robles, and Taft. You're talking about California's oil country here, maybe a few almonds too. And these people took it seriously. And this was before an earthquake. 31% of the people in Paso Robles, for example, sought information. 23% of the people in Coalinga rearranged their household items to make them safer. How many of you have not taken the heavy items off the top shelves in the kitchen and put them on the bottom shelf? How many of you have not done that? That was going on in Coalinga. 28% of the people in Paso Robles finished doing their emergency supplies. 14% in Paso Robles developed an emergency plan. 1% developed a neighborhood plan. We'd be very upset in Rancho Mirage with this number because we're really trying to get local communities to prepare to go through it together rather than on their own. Case 3. A forecast was made for the entire San Francisco Bay Area. 2 to 30 years after the Loma Prieta earthquake. Here's the forecast. A working group in California on earthquake probabilities said there was 50% chance of an earthquake in the whole state. On 17th of October, the Loma Prieta earthquake happened. September 9th, 1990, a 30-year forecast came out, revising California quake probabilities up to 67% in the Bay Area. And in 1990, once again, bless their hearts, the San Francisco Examiner hit the street with a big colored magazine. And the magazine said, "The next big Bay Area earthquake may happen sooner than you think." And you flip through the pages, and it told you why the scientists thought that, and it told you what you should do to get ready. That very information, refined a bit about what to do to get ready, is in the brochure that was on each of your seats. And in 1991, sociologists began collecting elaborate research data on what people in the Bay Area did. Take a wild guess. Who do you think the sociologist was that collected the data? It was me, yeah. The population study was 500,000 residents in the Bay Area. High-risk counties were Contra Costa County and Alameda County. Moderate counties was Sonoma County, San Francisco County, Marin County, and San Mateo. And lower risk counties was Santa Clara County and Santa Cruz County. What did people do? The first column of numbers is what they had done before the insert was distributed. The middle column of numbers is what people did after the brochure was distributed. So here's an example. Before the insert, 44% of the people in those counties had stored food and water for earthquakes. After the insert went out, 31% more did the same thing, and so on and so forth. And we saw that people were in action. But in addition to studying the public, we also studied what businesses and government did. And this gets really interesting. Basically, county agencies, state agencies that had offices in the area, and federal agencies with offices in the area updated their disaster response plans. Some of them took initial actions to get ready. Notice it was the federal government who had done the least until the insert was distributed. Some mitigation actions were taken. 30% of corporations did things to protect their contents. And here's another example. You know, Pacific Gas and Electric Company has its main building in downtown San Francisco on Beale Street. They evacuated the building and they had it completely retrofitted to go through earthquakes without damage or without much damage. Then they moved back into it. They spent millions of dollars because of this forecast. Now, case 4. This is us. The Salton Sea, a forecast was put out several days before the earthquake was supposed to happen. Here's the forecast. On September 29th, as of 10 p.m. on September 27th, there's a 0.03 to 1%, that's 1 in 3,000 to 1 in 100, chance of a magnitude 7 or greater quake on the southern San Andreas Fault within the next 7 days through October 4th, 2016. They said it was based on calculations by USGS scientists, that it was reviewed by the California Earthquake Prediction Evaluation Council, that it was based on a swarm of quakes near the southern San Andreas Fault at the Salton Sea, which is where the fault bends, and that the swarms can mean that fault creep is going on, which can cascade into a fault rupture. And then they went on to say the San Francisco quake of 1906 may have been triggered in this way. That information was sent to everyone sitting in this room. I freaked out because I know you don't convene the California Earthquake Prediction Evaluation Council on a lark. And I know credible scientists don't stake their reputation to make forecasts like this and then have it not happen. And then we heard that OES issued an earthquake advisory through October 4th, 2016 for Ventura, San Diego, San Bernardino, Riverside, Orange, Los Angeles, Kern, and Imperial counties. The state of California, the governor's office of emergency services, doesn't issue an earthquake advisory lightly. Now, what did people do? We don't know. It wasn't studied. But informal information, anecdotal information that I collected is basically people didn't do much. Let me give you an example. A fire chief for another city, not my city, called me up. I'm not going to tell you what city it was. He knew me. And he said, Dennis, what do you think I should do about this earthquake forecast? And I said, well, I said his name, not much now, it's over. Had you called a few days ago, I would have made some suggestions, but I wouldn't worry about it now. Now, what are the implications of that data? The data we have about how human beings respond to earthquake forecasts before the earthquakes we have data on and after earthquakes, for wherever it is that they happen to be. What can we, based on those case events, conclude about how and why people here, us, might respond to future forecasts? Well, here are my conclusions. Some of us will respond, but some of us won't. And it applies across forecast types. It applies in different environments, before and after a quake, and different time frames. Shorter forecasts in days versus longer. What contents of the message will matter the most? The contents of the quake forecast message we receive would be powerful drivers for what we think and perceive and do and don't do. What I just said is, Human beings don't respond to scientific objective fact. They respond to the words that they're presented with. Words matter. What are the key elements of a forecast from a public response point of view? Most of us will prepare if a future forecast message covers 4 topics: the potential of the quake, the size, time frame, and location. That you can count on getting from the physical scientists. Second, the possible consequences of that quake. Third, what actions you should take by when. And last, how those actions will reduce the consequences. That information you'll get depending on the quality and level of training of your local emergency manager and the news conferences they may or may not hold. Now, how the forecast is delivered also matters. Forecast delivery will influence if we prepare or not. More of us will prepare if a message delivery is repetitive, not just issued once. You know, for the Salton Sea forecast, I only heard it on the media once. In order to be effective with human beings, if you want to motivate action, it has to be repetitive, over and over and over and over and over. You've got to sell risk information like Coca-Cola sells Coca-Cola. It has to be delivered over diverse communication channels. You have to hear it on TV, you have to hear it on the radio, you have to see it on Twitter, you have to, et cetera, et cetera, et cetera. You got to have people from different angles. It has to come from different message originators. Yes, we'll all want to see Tom Jordan on TV. Lucy Jones, no doubt, might be speaking out. There'll be other scientists that step forward, particularly those that work at our local colleges and universities. And there needs to be vigorous media coverage. Now, what we had in the communities that the public responded was vigorous media coverage. By the way, we also can see, if you look at the data, that more of us will prepare after a forecast if we already know about general quake risk, aftershocks, forecasting science, and what to do to get ready for earthquakes. So now, all of you that had a brochure or sitting on it, feel that brochure. That's why you're here tonight, to get educated about general earthquake risk, thanks Tom, aftershocks, thanks Tom, forecasting science, thanks Tom, what to do to get ready for quakes. And that brochure, you can even thank Tom, because it was his organization that led the way to bring all the different preparedness experts in Southern California together to come up with that list. Tentatively, as the sociologist in the room, and this is the million-dollar slide, what we do after a forecast will be more influenced by the intensity of forecast publicity provided by the media than anything else. Not the probability, not 1 in 10 versus 2 in 10, not the time frame. We had forecasts issued for 10 years and people got in action right away. Our behavior will be the result of the intensity of forecast publicity. The bottom line. There's no reason anyone in California should wait for a forecast to get ready for earthquakes. Where do you think you live? We should prepare now anyway. How to prepare is in the brochure that we gave each and every one of you, and I'm proud to say that a lot more than what's in that brochure is available on the City of Rancho Mirage website. You need only click on search for City of Rancho Mirage, scroll down the title page, it says emergency preparedness, click on that, and a Disney cornucopia of preparedness information is at your disposal. This is the brochure about how to get ready, and special considerations if they predict a short-term or provide a short-term, I'm sorry I used the word predict, forgive me, Tom. If they forecast a short-term, in the short term, an earthquake, what would I do? You want to know what I'd do, given what I know and who I know? I'd park my vehicles outside of my garage where nothing could fall of them. And I don't care what the president of my HOA says. If it were possible, I'd try to keep my family together so that if the quake happened, one of us isn't at Costco and the other one in the Thunderbird Country Club. I'd stay, if I could, stay home. So that if the earthquake should happen, I'm home when it happens. And that's easy for people in our age bracket, by and large, to do. Most of us don't work. I'd practice drop, cover, and hold on. I'd relocate falling objects in my home, and I'd secure my emergency supplies so they don't go rolling and bouncing all over. In short, when the USGS, its scientists, the California Earthquake Prediction Evaluation Council, and the Governor's Office of Emergency Services talk, I recommend to us that we listen. I'd like to thank you very much for your attention.